Hello and welcome everybody to Advent of Code 2022, day 13. So today's problem was pretty fun. I didn't think it was too difficult at first. I thought the problem might have been more difficult than it was going to be, and I got a little bit scared. But then I sort of just started stepping through it logically, and it actually, I think, ended up shaking out not too difficult. And it was another one of these examples of a a question where, or of a day where the part one solution is basically a tool that once you have it, you can use it to solve part two. And the part two doesn't end up being all that difficult once you have the part one solution done in the right way that makes it reusable, which is pretty cool. I wasn't really sure exactly what they were going to try and do. Happens that the way I wrote my solution worked perfectly to just plug straight in for part two, and the part two code, really simple, gives me the answer pretty much straight away. So with that said, let's dig into our problem. Day 13, distress signal. So you've climbed the hill and you're trying to contact the elves, except what you start is you receive a distress signal, and your device is still working improperly because you find out that the distress signal is all out of order, so the packets aren't in the right arrangement. Our puzzle input is a list of these packets that are all out of order, and you're given some logic to determine the order of the packets should be in. And basically what you have to do is you have to go through the list of all the packets and determine which are in the correct order. So what you have here then for your list of inputs is you've got pairs of packets all split out by a blank line. And what you have to do is you have to figure out which two of each of these pairs of packets are in the correct order. And there's a whole bunch of logic to determine how you figure out if this is in the correct order, if this is in the correct order, if this is in the correct order, so on and so forth. The answer then that you're asked to provide is you're asked to provide so we're told that this is index 1, this pair is index 1, this pair is index 2, 3, 4, and you're told to provide the sum of all of these pairs that are in the correct order already. So if we do a comparison check between these two and determine that they're in the correct order, we would return, say, a true, and then we'd record that, the index for that, and then we'd sum that up with all the other ones along the way. The logic to do this is a little bit convoluted. Basically, we're told that for any given list, you start by comparing, so say the first one is the simplest one, you start by comparing each of the two integer values. So you say you compare 1 and 1, and they're the same, so you skip on to the next one. You compare 1 and 1, they're the same, so you skip on to the next one. Now you compare 3 and 5. You're told that the left, so we're going to say, so this is the top value and the bottom value, we're going to call these the left and the right for the comparison. So if the leftmost value is smaller than the rightmost value, then they're in the correct order. So then we exit out of this and we say that yes, these are in the correct order. That's true. Did I get that right? Yes. The lower integer should come first. I did get that right. We're then told that if you have, where is the other one? Yes, so if both values are a list, so in this case, we've got a list and a list here. So then what you do is you start going through each value in the list and you do the same comparison. Again, if you determine that, so if you start comparing each value and if one is smaller than the other, then you exit early, and that's that. So if the left one, is smaller than the right one, then you exit early, and that's that. What else happens then? So then the only other case that we have, so then the other thing is if you have two arrays that are side by side and you start iterating through them, if one of them runs out of values first, and if that one is the leftmost one, then you also exit, because that comparison is you're saying that the left one is smaller than the right one, so that exits. And what else have we got? What's the other? So then the other case is where you have, say, one integer value and then one array value. If that is the case, if that's what you end up with, you replace the integer with an array that just contains that integer, and then you compare this integer as an array to this array. And you do basically the same check as if these are both arrays. But of course, both of those array checks are actually just checks of lists of integers. So you'll start to see a pattern here where if you were to nest down through everything at the bottom level, all you're ever doing is just comparing two integers to get your value of true or false for whether it's which is smaller, left or right. The only change to that is where you run out of integers in one list or the other, and if they were all the same up to a point and then you run out, then you pop off to the next one. Okay, so that's a little abstract. Let's look at the code and see if we, and of course, actually, to highlight, they give you a full detailed breakdown of how all these comparisons work for each of the cases in the sample. So let's have a look at my code for part one. The first thing I do, I start reading each line, and I basically create a hash of all the pairs with the index for each pair as the key, and then inside the value, I have a left and a right. So just loop through it, read each line, and assign that to a left and a right. Then after that, we get into the meat of what is the comparison operation. So I go through the list of every single pair. For each set of pairs, I do this left versus right comparison check where I pass in the left and the right. And that will spit out then an order for me, which is just a Boolean. And at the end here, I'm making a sum based on all of the ones where that order is true. And then I output the sum at the end. So this comparison check, this is basically this function here is the entirety of the meat of this solution. And it's not too bad when you go through it and step through it logically. So first thing I'm doing is I assume that both of these are arrays. I figure out the size of those two arrays and get the largest value. That'll become apparent in a minute. So then I create a loop which will go from 0 up to a maximum of the largest value. So if these two arrays were the same size, if they're both arrays of length 5, this loop would iterate 5 times, and the index would allow me to check the left and right value for 0, 1, 2, 3, 4, all the way up. So I can get the values to do their comparisons on. So this is just for the pure integer case, but it doesn't have to be for the pure integer case because it can be any array that you pass in here, basically. Any arbitrary nested array of integers can be passed in here. So then we get a left value and a right value by taking the two arrays that are inputs, and we take the indexes here, which we've figured out are here. The first thing we check for is we check for the case where one index is gone out of bounds for the other. Basically, in Ruby, if you overflow the index, you just get a nil out of it. I know there should be no nils in my list. So I check if there's a nil in the left and no nil on the right, I return true, which means that the leftmost array has ran out of values before the rightmost array, so I get a true returned, and that's the end of that loop. And this the opposite then true for if the rightmost array has run out first and the leftmost hasn't. So then I know it's backwards, basically. The next case is the simple case where you're just comparing two integers. So this should be pretty much the lowest level case. So you should only get here when the two things that you're comparing are just two lists of integers, and that's it. And so for this case, all we do is check if the leftmost value is smaller than the rightmost value, or the leftmost value is greater than the rightmost value, and respectively return true or false. And yeah, that's it. This is also another end terminating case. So there's the two different terminating cases we have in this loop are when we're just comparing integers and we figure out what the one integer is bigger than the other, or when we have two lists and they're not of the same length, so we figure which one runs out of values first. Aside from that, now we need to do a little bit more work. So we've got 3 cases that we need to deal with. One is where the left is an integer and the right is an array. The left is an array, the right is an integer, and they're both arrays. So in these cases, it's pretty simple. The simplest case is if they're both arrays, we just pass them back into this function to start the recursion again. We got our left, we have our right, and that's it. So then that steps in here, does the same thing. If they happen to be 2 pure arrays of integers again, then we'll end up hitting either of these 2 clauses, and that will give us our answer. And the other case then is where the left was just an integer, so we now make it into an array and compare it to the right, and the same vice versa. And then that'll enter back into here, and it'll do the exact same checks. If they happen to be 2 pure integers, we'll exit on one of these cases. Otherwise, we'll end up back down in here, and we'll just keep going until we end up at the very end. There's one last case that can happen, which is this nil case down the bottom. So this case basically only happens where you end up with sets of integers to compare that. Sorry, let me get this right. It's what is this case? I can't remember it now. It only happens where they're this is a case that happens where you've got equal values of integer, is it? Damn, I can't remember what this case is now. That's embarrassing. Why does that happen? It does happen anyway. I can't remember this case now, but effectively you can get there is a nil case in here, which is where the comparison, is it the comparison here? Oh, I think it's the case here where where it ends up being 2 integers. Yes, that's what it is. Sorry, it's the case where you've gotten to the very bottom and it's just 2 values that are equal. So there's nothing more that can happen. So you've gotten to the very bottom of your stack and there's 2 array values and they're both just equal numbers. So based on this logic, one isn't greater than the other, but we're already at the very bottom of the stack, so there's no next number to check or anything. So you end up just need to return out of that, but it's not a terminating case. So you just will return nil basically, and that's it. And that also is accounted for in here, that if we get to one of those nils, we don't want to return out of the entire loop. So we need to check for that nil. And it happens that the case never arrives where that actually just ends up in an infinite loop or anything. It'll always end up returning, and it should work, basically. So it's not crazy complicated. If you step through the rules one by one that they provide for you, it's not actually that bad. If you look at it, it can seem a bit overwhelming, but I think realizing that you're essentially reducing the arrays always down to just simple comparisons each time, and you just have to plug in new sets of arrays each time, that makes it a hell of a lot easier to do it once you start thinking about it like that. And yeah, let's run my part 1, and yep, very fast, runs, no problems. So part 2 now, again, they don't change the problem, they don't really mix it up, they just ask you to use what you've written in part 1 to solve part 2's problem as a tool, basically. So what they tell you is, they tell you to disregard all the splits and to now reorganize your entire list. They also ask you to inject 2 new packets into here, which they're calling these divider packets. So what you do is you are going to inject these 2 divider packets into all of your list of all of your packets, and then you're going to effectively sort the entire list based on the rules, the comparison rules that you came up with. And then at the end of it, you're going to find the index of this and the index of this and multiply them together, and that is what they want for you to give as your answer. So basically you just have to implement sorting, and that's pretty simple to do if you've written your logic nicely. So let's go to my part 2. There's a slight difference up here in how I build it. I do away with the hash of pairs just read in every single packet into an array, add in my two divider packets. Remember, you can add them in anywhere. It doesn't actually matter at all because you're just going to be sorting the entire list anyway. And then this compact operation is because this has empty lines in it, which come out as nils when you run this. So I just put a compact in there. So I just have an array of all of them. And then, so it's the exact same sorting method as before. I just call the Ruby sort function, and the sort function in Ruby gives you this nice block representation where you can essentially provide like a left and a right, or an A and a B comparison here. So what I do is in the sort method, I have my left and my right. I call my left versus right function. That gives me a result. In this case, if the result is nil, it's effectively I've compared the same value, a value to itself. So you want to return 0 into the sorting algorithm. Then if the result is true, so that means the left is smaller than the right, you want to return a negative value, so return -1, and then +1 for the other case where the right is bigger than the left. And then, yeah, you just run this, and this goes inside and runs its sorting algorithm. Could be anything, doesn't matter. You could implement your own sorting algorithm here. You could write bubble sort or whatever you want if you wanted to. I didn't do that. I just knew I could identify that this was a sorting problem. I had a comparison function written that worked quite well, so I just plugged it in here and let this sorting algorithm do its job. So now I have a sorted list of all the packets, and with the sorted list of the packets, you just loop through it, find our two divider packets, record their index, and then I get the product of their index, and that gives me my answer. And that's it. Nice and simple. So part 2, again, very efficient. It didn't take that much time for me to actually implement it either. Now, the real key with this is if you wrote a very simple left and right single function sorting method, then you could plug this into a sorting algorithm really easily that already exists. So I think most languages will have a custom sorting thing where you can just plug in, the lambda or whatever that is to actually do the comparison between the left and the right and give some output. You just have to look up what the interface for that is. Or you could write your own sorting algorithm. Hey, it's up to you. I opted not to do that just because, I suspected that this would just work, and it did. If this didn't just work and I had to do something more complicated, then I would write some sort of sorting algorithm if there was extra bits and pieces in there. But it's just a really basic, simple sort. So I didn't reinvent the wheel. I just reused something. But I think it's kind of clever to spot that. And I'm sure most people, or a lot of people, will have spotted that you could just do that. But yeah, made me feel smart, which is always a good thing. So yeah, that is about it for day 13. I had quite a bit of fun doing this. It was a bit easier than I thought it was going to be. It was kind of scary looking at it at first, but then as I teased through it bit by bit, stepped through it, it actually became not that bad. So yeah, I'm pretty happy with today. I hope you guys enjoyed it. I hope this solution helped you, or it gave you just a different perspective on it. And yeah, thanks for watching, guys, and I will see you all tomorrow for day 14. Bye bye.